Last but not least, in this chapter 5, we have 5.6, which is factoring again, but it's just those special cases that we talked about before, the perfect square and the difference of squares. Keep in mind, when you're looking at what type of factoring, again, the first one you always want to look for is that common factor. Then look to see if it's a simple trinomial, then a complex, and then you can look at your special cases. So, going on to the first type, which is a difference of squares. Here are some steps on how to factor the difference of squares. Now, I want to note this part here, the or part. If you don't notice that it's a difference of squares, you can just carry on like usual. So for example, in this case, there's no middle term. All the other trinomials we did were exactly that, trinomials. There were 3 terms. This only has 2. What you can do, though, is say that it's 2y squared plus 0y minus 9. And then you'll carry on just like your regular complex or simple trinomial depending on how it is. So even for this one, for example, x squared plus 0x minus 9. So you're going to look for 2 numbers. This is simple here, a value of 1. 2 numbers that multiply to get negative 9 and add to get 0. But if you don't want that and you want an easier shortcut, you can do exactly this. So in a difference of squares, if you recognize it, it's going to be 2 brackets. And in those 2 brackets, one of them will be plus and one of them will be minus, which you may have noticed from the multiplying before. To get what goes in the first spots here, you take the square root of the first and the square root of the second. Okay? And so if it goes perfectly, then you would put that square root of the first term in this spot and this spot, and the square root of the last term here and here. Or again, just do it like normal. So first we're going to try to see if these are difference of squares. Now remember, these are your 2 key words, difference and squares. So looking at this first one, we have 2y squared. Is that a perfect square? Well, the y is, because that's y times y, but 2 is not a perfect square. 9 is, because you can do 3 times 3. So since the is not a perfect square, this one would be no. So what it means to be a perfect square would be like 3 times 3, or x times x, or negative 5 times negative 5. Exact same things multiplied. Here's a case. We have x squared, x times x, so that's a perfect square. And this one, you can do 1 times 1, so that's a square as well. The last part to check is it a difference? Because it's a difference, it is, so it's a difference of 2 squares. Here's another one, b squared. Well, b times b, so that's a square. 25a squared, that will be 5a times 5a, so that's a square. However, notice that it's a plus. So this one is not a difference of squares because it's not a difference. It's a sum here. So let's factor this one here. It's a difference of squares. First, we got to check that. X times x, so that's a square. 3 times 3, that's a square. And we have the difference. So quickly factored. We take the square root of the first term. One of them gets a plus, one of them gets a minus. So the square root of x squared is x, and the square root of 9 is 3. So again, like we said above, you just take the square of each. So we put the x in the first spot since it was the first term. So the x goes in the first spot. And we took the square root of 9, and we got 3. So the 3 goes in the second spot. And there it is factored, x plus 3, x minus 3. Now in the case of a perfect square trinomial, that's one of those cases where we would have the a plus b squared. So it's the exact same thing times itself. And so to check if this is true, the first and the last terms should be perfect squares. So looking at this, to get 3x squared, we could take take the square root of that, and you get 3x. The last one should also be a perfect square, and so the square root of 49 is 7. Now, to double check if this is a perfect square, you would want to check that the middle term is 2 times the product of these numbers. So if we multiply 3x times 21, or 3x times 7, we get 21x. Times this by 2, and we get 42x. So as you can see here, our middle term did check out, and so this is a perfect square. How would we write that in factored form? Well, the thing that we got in the square root is written as such, 3x as the first term, 7 as the second term. Because they were all positive, this is positive, and then it is squared. So there's a few examples here to try. Try this first one. hit pause, and then you can check back your answer in a second. So hopefully you got this far. You took the square root of each part. You got 3t and 1. And then you check them multiplying those. 3t times 1 is 3t. And then timesing that by 2, you get 6t. I want you to notice, though, there's a problem right now in that the middle term is negative 6t. So the difference from this, to make this a negative 6t, we can actually make this value a negative. So 3t minus 1 squared. And you can also check this by expanding 3t minus 1, 3t minus 1, and you should get back to what we have here. Now, I just want you to remember that if you do not like this method of doing the quick square root, you can still always do product sum or the box method, again, because this one here is a complex trinomial. So you could do the product of 9 and a sum of negative 6 and go through the whole process that way. It does not have to be done this way. But either way, we're able to get our factor. If you have any questions, here's a few more that you can try. Try at least one of them and write down any questions that you have and bring them to class.